Okay, here is an Alex problem that deals with half-life. And a lot of questions are asked like this, so let's tackle it the way I might do it. The rate at which a certain drug is eliminated by the body follows first-order kinetics with a half-life of 22 minutes. Suppose in a particular patient the concentration of this drug in the bloodstream immediately after injection is 2 micrograms per mil. And so what will the concentration be 110 minutes later? Alright, so one way that we can tackle this, let me go over here to where I can write, is this. One thing you can start to do is you can take the total minutes, which is 110, and divide that by the 22 minutes, which is the half-life. So total divided by the half-life, and in this case it's going to equal exactly 5. Because it equals exactly 5, we can tackle this problem this way. I'm going to say here that this is the number of half-lives. Make a little table here. This is the minutes column, okay, and this is going to be the concentration column right here. So at time equals 0, okay, then that's going to be our 0 half-life. There are 0 minutes at that point. No time has elapsed. And our concentration is going to be 2.0. And these are going to be in units of microgram per mil. Okay, let's just keep going. After one half-life is 22 minutes. Then the concentration is going to be 1 microgram per mil in the body. After 2 half-lives, then that's going to be 44 minutes. Concentration has now dropped to 0.50 micrograms per mil. Alright, we're not up to the 5 half-lives yet, so at 3 half-lives, it's going to be 66 minutes. Concentration has now dropped to 0.25 micrograms per mil. Alright, and so now we're up to the 4th half-life, which is going to be 88 minutes. We should be at 0.125 micrograms per mil. It just keeps halving every 22 minutes. And finally, at the 5th half-life, there's going to be 110 minutes. And this is going to be 0.0625 micrograms per mil. And so just by going through half-lives this way, we know that the concentration after 5 half-lives, after 110 minutes, is going to be 0.0625. I think we need 2 sig figs. And so that's going to be 0.063 micrograms per mil. Or if you want to do scientific notation, that is going to be 6.3 times 10 to the negative 2 micrograms per mil. Alright, so let's just head back to Alex, make sure we did this right. Okay, 0.63, and so if I put in 0.063 micrograms per mil, the units are already there for me. We should check that, and we should get the right answer for that. So that's one way that you can tackle these half-life problems in Alex that are generally going to give you half-lives that are going to be exact in this case.